Dear student, after a long gap, we are again going to start the subject. So far we have seen so many areas including corrosion control. Many parts of corrosion control are already covered. Today we are going to discuss on one of the most important aspect, that is coating. To be honest, coating is considered to be the most oldest and perhaps most extensively used approach all over the world. Actually, coating material isolate the underlying structure from coming in contact with the corroding environment, and therefore the coating material we are going to apply, we are going to use, must comply with two very important parameters. Number one, the coating material must be inert chemically to the environment at a particular prevailing temperature and pressure. And second most important parameter is that the coating material must be able to prevent the penetration of corrosive component or ingredient of the environment into the metallic structure. And therefore, we have to be very, very careful before selecting a coating material. And coating material, when applied, it may follow two different approaches. Number one is anodic coating, and number two is cathodic coating. Let us start with anodic coating, and it will be followed by cathodic coating. Anodic coating. In this approach, the metal being used as a coating material will behave anodic with respect to the base metal as it stands, or we can say electrode potential is less than that of the base metal. Generally, coating material being used are zinc, aluminium, cadmium, as their electrode potential is less than that of the base metal, that is iron. And therefore, if however any part of the coated area get punctured, galvanic cell is being produced, and automatically coating material being stands higher, it will become anode, and punctured area will become cathode to make a complete cell. In case of galvanic steel, what we have seen here, galvanized steel, this is the coating. This area is coated with zinc, and this area rupture has taken place, and this part and this part, it is unexposed part, and therefore once this is ruptured, automatically this zinc coated area, zinc will become your anode. It will undergo spontaneous oxidation like this, and as we know that in an electrochemical cell, whatever corrosion takes place, it takes place on anode only, and thus your underlying metal iron get protected. Here actually zinc is protecting the base metal iron sacrificially. It is sacrificing itself to protect iron. This is all about your anodic protection. Now we'll be talking on cathodic protection. Here the principle is just opposite. Cathodic protection or coating. Here the principle is that the material being used here will have higher electrode potential than that of the base metal, that is iron. Here it is written, tin coating, it is tin. Tin stands below in the galvanic series than iron, and therefore it is more passive, it is more noble than that of iron, and therefore the basic principle on which this coating works is that being more noble, it is more corrosion resistant than that of the base metal. Here in this case, when tin coating is applied on iron or steel, whatever it may be, once it is fine, so long the coating is there on the entire metallic structure. Unfortunately, if there is any crack or if there is any kind of punctured on the metallic surface, the rate of corrosion will be very, very fast, and it will be very, very devastating. Here, as in the case of tin plated steel, the entire steel structure is coated with tin. So long there is no rupture, it will go as it is, there will be no corrosion. But because of any reason, if there is a ruptured area, this area, automatically tin will become your cathode, making iron anode. You can see this area will become unprotected part, this tin will become your cathode, and this exposed area will become your anode, and iron will spontaneously undergo oxidation, as a result of which rate of corrosion will be very, very high. And this type of protection is very safe so long the entire metallic structure remain protected by the coating. Once there is any crack or there is any rupture on the metallic surface, this kind of coating is very, very dangerous. So this is all about our today's lecture, and we'll carry forward in our next lecture. Please go through the video very carefully. If there is any doubt or confusion, please get it noted, and we will discuss and clarify your doubt in the next lecture. Thank you.